Hello everyone, welcome to this video on analytical simplification. This is unit 6 of computer methods in power system for BTech. In this video, we shall look at how two component theory uh, model, that is two component theory for analyzing unsymmetrical fault, has been derived from three component model, and this is what the question they asked: derivation of two component model from three component model. So already we know that. So let us first revise what is three component method. Already we have learned symmetrical components. So already in that we learned that a unbalanced voltage vector. Suppose if you have an unbalanced voltage vector, say VA, VB and VC. This is the voltage vector, and let us say that it is unbalanced because of some unsymmetrical fault. And we already learned that these can be resolved into three components. One is positive, that is VA1, VB1 and VC1. This is the positive sequence set. Another is negative sequence set, that is VA2, VB2 and VC2. And there is another zero sequence component, which is VA0, VB0 and VC0. This is already we learned. It is told by Fortescue that any unbalanced vector can be resolved into three balanced vectors. Now we know the relation between between this unbalanced phasor and these sequence components. So this is the equation already we have learned. Here h is equal to 1. Kindly note here the h is equal to 1 we are considering. So wherever h is there in the proceeding derivations, so there you please put this h is equal to 1. So already we know that this equation already we have derived in our previous videos. So this is three component method. Okay, and now what is the concept of two component method is that this zero sequence component is kept as it is, and these two are combined to get another component. So there are, from positive and negative, there are two sets are obtained. One is called VA summation, called as positive sum. This is called as positive sum, and another it is obtained VA delta. This is called as positive difference, and this is as usual zero sequence component. So what is this? How this VA0, VA summation, this is called as VA summation, positive sum, and VA delta, which is called as positive difference. These components they are obtained by adding positive and positive plus negative sequence component. For example, VA1 minus VA2, this gives one component of VA summation. Similarly, VA1 minus VA2 will give you another component of VA delta. And this theory is called as two component model. So let us see here. Now we can see here. This is the second row and the third row. Now what we will do? We will obtain one VA1 minus VA2. Let us do VA1 minus VA2. Then we will get one equation. This is sorry, VA1 plus VA2. Let us do. So we get one positive sum, and let us do the subtraction of these two rows, that is this and this row, that is VA1 minus VA2. We get this as VA delta. This is called as positive difference. So we get these two equations. Now these two equations, positive sum, we will replace, we again replace back to this second row, and this difference equation we substitute it to the third row. So we get the, here it is written, adding and subtracting the second and third row and replacing the same by resulting sum and difference equation, we get the equations as follows. So we get this equation. So the first row we are not disturbing, we are keeping it as it is. That is what here zero sequence component is kept as it is. But how do you get this VA summation? VA summation, this is what the second row, this second row is obtained by adding the first row and the second row, VA1 plus VA2, which is called as positive summation. Okay, and the third row, that is a third component, it is obtained by subtracting VA second row minus third row and replacing the third row by this equation, which is called as VA delta. It is called as positive difference. Okay, and this is called as two component model. This is called as two component model. That is, from three component we are deriving uh, basically two component. Here it looks three component, but basically VA summation and VA not, they are very similar. They are very similar, and using this VA summation and VA delta, we can have simplification in terms of analyzing unsymmetrical fault. So now let us put this matrix form in the vector form. So VA summation delta, it is the vector of VA naught, VA summation, VA delta, and this is the matrix here. This is the matrix B inverse. B inverse. In our previous derivation, we were taking it as A inverse. Just note down it is. Uh, Now here, sorry, this is A inverse matrix, what we are taking in our three component method, but now here it is symbol is used B. It is B inverse matrix, and this is VABC, that is unbalanced vector. So this is called as two component model. This is called as two component model. And here this is what we had VA not, we can say, or something like that. Uh, what symbol we were using there? Vs. Vs equal to A inverse into V. So this is three component. Vs is the vector of three components. A is this matrix A inverse, and V is the vector of this unbalanced vector. So this is three component model, and here whatever we have, this is two component model, VA summation delta. So we understood how this is obtained. Simply in the three component model, the second row and the third row, they are added, and we get this second row, and second row and the third row, they are subtracted, we get this third row. That is called as two component model. So inversely we can write, so V0 summation delta is equal to B inverse into VABC. So if you take this on this side, it becomes B. So this is what we have here in this equation. So what is B? B is this matrix. So H already I told this value we can be taken as 1, and this is, we can see here the third row, the second row and the third row, they are very similar. So this is also called as two component model. This is called as two component model. So this equation helps to analyze the unsymmetrical fault. So in the three component method, we were requiring three sequence networks, positive, negative and zero sequence networks, and we were requiring their connection. So it was complicated, but now that three circuits, we are reducing it to two circuits with the help of this two component model. So which is explained here. So in the exam, if they ask you this equation, derivation of two component model from three component model, you can end up into this. But if you continue with this uh, concept, that is showing that three sequence networks, how they are reduced to two sequence networks, that will be, they will get more marks. Okay, if you write this, it is better. So here it is shown, consider a positive, negative and zero sequence network. So this is zero sequence network. We can see Z0 is zero sequence impedance and VA0 is zero sequence voltage and IA0 is zero sequence current. Similarly, this is positive sequence network. So here again I am telling this H, you can take it as 1. And what is EF? VF indicates here, VF is nothing but, this is the Thevenin voltage. So this is Thevenin voltage seen from the fault point. Or okay, so then Z1 is the impedance, positive sequence impedance, and I1 is positive sequence current, VA1 is positive sequence voltage. This is negative sequence network. Similarly, now what to be remembered here? This is passive network. Zero sequence network is passive. This is passive and this is active because we have a source. Now in two component, now here the equations are written. So we can say here, we can see this equation. I will just write this equation VA naught here. It is equal to, this is the voltage. VA naught is the voltage drop across this. So it is equal to IA naught into Z naught. So this equation, it is written here in the matrix form here. V naught is equal to 0, and yeah, this is minus because the current is flowing from top to bottom. So you have positive here and negative here voltage drop. So it is minus you get. So Z naught into IA naught, and these are so this equation you can see it is put in this matrix form here. Similarly, we can write equation for VA1. So VA1, it is the equation like VA1 is equal to uh, it is equal to HVF minus IA1 into Z1. So this equation is put in this row, second row, and similarly the third equation is written for VA naught and it is written here. It is in the matrix form. Actually here it is Z2. Actually here it is Z2. But the important point to be noted here it is that this is one why uh, the concept behind the transformation of three component two component method is that in the transmission, in the power system, we have transformer, we have generator, we have transmission line, and for most of these power system component, the positive and negative sequence impedances, they are almost equal. For transformer and transmission line, they are equal. For generator, there is a light difference, but without loss of accuracy, we can take Z1 is equal to Z2. So here we can take it as Z1. Actually, here it is Z2, but we can assume that Z1 is equal to Z2, that positive sequence impedance and negative sequence impedance, they are same, we can assume. And because of this equality, we are able to transform three component to two component. This is very, very important concept, that the positive sequence impedance and negative sequence impedance, they are assumed equal. Now, now let us do that work. Now let us transform this equation as we have done previously. This is three component model. Now let us transform these to two component. So how we do? So what we do first addition of these two, VA1 plus VA2. We add, and then we subtract VA1 minus VA2. We subtract the second and third row and replace them by resulting sum and difference quantities, as we have done in the previous derivation, that is transforming three component model to two component model. Here also we can do same. Now we get this equation. So this equation is same, va naught is written same, that is not changed. Now we are adding these two and we are putting the quantity, the summation, back into the second row. So this is VA plus VA2. Now this we are writing at VA summation, that is already we learned, and sorry, VA summation. And again, the whatever resulting quantity we have, we are putting it in the second row. So here we get IA1 plus IA2, and then now you subtract the second row and the third row, that is VA1 minus VA2. So this is VA delta, positive difference, and HVF. So H, I told you can take it as 1. In your in your exam, you don't write this H, simply write VF, and here I told that here Z2 is there, but we are writing it as Z1 because we have assumed positive sequence and negative sequence, they are equal, and here it is the difference current, I1 minus I2. So this is the equation we get after adding second, third row and subtracting second and third row and replacing them into the second and third row respectively. Now let us move. Now here you can see very important, what is that, that you can see what happened with this, that the second network, now the second equation, this is the this is uh, this is actually, this is positive sequence network and it is active. Now here also we are getting positive sequence network and it is active. Why it is positive sequence network? Because we have this source. Now by doing this work, this negative sequence, here it is negative, but now it is transformed to positive and active. Why it becomes positive? Because again we have a source here. Okay, and they are identical. Only the difference is that here we have summation. In terms of network, I want to tell, in terms of network, they are identical. So this positive, we can say positive sum and negative sum, positive difference, they are identical. They are identical networks. Only the difference is that either we have summation of voltage or there is a difference of voltage. Otherwise, in terms of network, they are same, and hence the three networks, they are reduced to two networks. So it is called as three component. It is called as two component model from three component model. Now here you can see the first row represents zero sequence network and the last two represent, as I told, they represent positive equations. The second row represent positive sum network and the third row represent positive difference network, and this is called as two sequence networks. As I told, because positive sum and positive difference network, they are same, we get only two networks. So here it is this. So this is zero sequence network. So we can see here. So this is VA naught and here we have IA naught and this is Z naught. This is negative sequence network and we have positive sum or positive difference network which are same. So we can, it is shown here. So You can see here the voltage is VA summation or VA delta, and the current is IA summation or IA delta. They are, only that is the difference. Otherwise, in terms of network, it is same. We have same again positive sequence network, and we have same voltage source. So our three networks here, what I want to say, the positive in three component, we have three networks: positive, negative, and zero. But now these three sequence network, they are converted into two networks: zero sequence network and positive sum and positive sum, which are identical. They can be considered as one network. So totally it becomes two networks. So this is how three component method is transformed to uh, two component model. So in this video, up to this only, we shall continue in the next video. Thank you very much.